All right, guys, welcome to another section of the course. Okay, so we're starting to discuss chapter 10 of the Steelwork textbook. So we're going to start with the first session on chapter 10, and that's 10.1, okay? So pretty much section 10.1 focuses on parametric equations, okay, and polar coordinates. So let's say parametric equations, and the polar coordinates. Okay, so we're studying more like a two-in-one. We're focusing on a two-in-one thing in this session. So let me start by saying that pretty much so far, we have actually discussed, okay, so we have discussed, curves that are described by, discussed curves that are described by y equals f of x, okay? An example of such is just when you say y equals x squared, okay? And as well as x equals g of y. That means y is a function of x is a function of y, okay? So now the question we're trying to ask first is that what if, okay, what if it fails the vertical line test and the horizontal line test, okay? What if it fails vertical and horizontal line test? Okay, so I hope that rings a bell, the idea of a vertical and horizontal line tests. How do you determine a curve? When you do the vertical line tests, when it doesn't cut the curve at two different places at the same time, okay? Or perhaps maybe the one on the top, as long as it doesn't cut it at 2 points, then you say it's a curve, right? So if it fails it, that means it does cut it at more than 2 different points. Okay, so that's the idea of the vertical line test. So now, but right now, what if we have a situation? Okay, so let me say, how about a curve like, okay, what if I have a curve that is kind of erratic? So this is my x-axis, this is my y-axis. What if I have an erratic curve? Suppose I have a curve that looks like this guy. Okay, what if I have such? Let me extend this x-axis a little bit. Okay, what if I have this kind of curves? Now think about it, you're driving, right? You're driving past some roads that are, that have twists and turns. Now over here, of course, this guy fails the vertical line test, because if I draw a vertical line across this guy, in some cases, it's going to touch this curve at 3 different points. And of course, it fails. So for the vertical line test, it has to touch it only at a unique point, just one. Okay, so let's just write a little bit. So let's say, suppose we have a particle. Okay, suppose a particle moves along these curves. Okay, if you think about bees, okay, think about the way bees fly or the kind of motion they have. Bees don't, they don't have a straight line motion. They just go here and there, kind of have twists and turns. So suppose a particle moves along this curve. Okay, and we cannot describe the motion of the particle with an equation of the kind. Now, what are we saying with this statement? That means for this kind of motion, we cannot claim that y equals f of x. Okay, so and that means but, all right, so but my x and y coordinates are functions of time. Now, what does this mean? It means at a particular time, you have a particular x and y. At time t1, you have x1, y1. At time t2, you have x2, y2. At time t3, you have x3, y3, on and on and on. Okay? Okay, so let's say at each time instance, at each time instant t, what happens? My x and y actually have a value. Okay, my x and y has a value that depends on t. Now, let me give you a very basic example, guys. Think about this. If I have my x of t, call it t. Suppose y of t is t squared. Now, when t equals 1, when t equals 1, what does it mean? It means I can determine x of 1. X of 1 is going to be 1. Can I determine x of 2? Definitely. Okay, y of 1 becomes 1. Now, when t is 2, that guy keeps changing. That guy keeps changing because x and y depends on the value of t. Okay. Thus, this can be described. This can describe, okay, thus can describe the motion with equations of the form. You have your x of t, which is a function of t, okay, and my y of t, or my y, I'm just going to stick to y, but of course, x and y depends on t. Let's just write x and y. Okay, or if I don't want to write it like this, I can just write it as x comma y. In coordinate form, this is f of t comma g of t. Okay, now that this actually describes how the position, okay, I know you don't like the theories, guys, but it's just, you know, sometimes we have students that do not like the theories. They just want to go solve problems. But the theories are the motivation behind it. What are we trying to say here? We've studied functions like y equals f of x, like y equals x squared, y equals x cubed, and the likes. So now we just want to have, like, take it a little bit higher, and now I want to study functions that depends on time or depends on the so-called t. All right, so that means it keeps changing from point to point. You're having different eventualities or different outputs or different results. Okay, that describes how the position of the particle varies with time. All right. Okay, so now let me safely mention, guys, that this equation that I have here is what we call the parametric equations. Okay, parametric equations. Let me write that in words. Now the curve that is described by this pair of equations. Okay. The curve is actually called, okay, still the same parametric equation, guys. So, but now it's a curve, so we just call it a parametric curve. Okay, so keep in mind that equation is called a parametric equation, right? The curve you generate from this equation is called a parametric curve. Now, there are three important things to take note of, guys, when we're talking about parametric equations. So let me write notes. Number one is that the t, the variable t, does not necessarily mean time. Represent time. Okay, t does not represent time at all, always. Okay, so we can even use a letter that is different from t. We can use small s. All right. Number two thing to take note of, guys, is that now when we start sketching the curves, you will get this part better. So we use arrows, okay, to indicate. We use arrows to indicate in what direction. Okay, so let me better put, in which we use arrows to indicate in which direction t increases. And the last thing to state that it has, these guys are important, is that the parametric equation can be of any kind. Can be of any kind, guys. It can be of any kind. Okay. So an example is that the parametric equation can be linear. It can be quadratic. So you have different possibilities. It can even be transcendental. Okay. So we have different possibilities with respect to the parametric equation. If it's linear, what are we saying? X equals t, and then y equals maybe 5t. These guys are linear, all right? So if it is quadratic, it can even be 5t plus 1. It depends, okay? So if it's quadratic, so let me just put 5t plus 1 so that you guys can know. Now, if it's quadratic, it can just be x equals, you have t squared minus 4, and you can have y equals, let's say, t squared. Okay? It all depends. All right. Okay, so now it's important to say sometimes, we're talking about t. What if t is restricted to a particular interval? Okay, so let's say that sometimes we only want to observe what happens. Okay, we only want to observe what happens over a certain interval. Okay, so over a certain interval, what does that mean? That means thus we're only going to trace, so thus tracing only a piece of curve. Okay, in that case, what are we going to say? This guy, the parametric equation, x equals f of t, y is g of t. But now we said it's just in an interval. So we're going to assume my t is between a and b. This guy becomes our parametric equations. So what's the difference between this parametric equation and the one on the top? The only difference is that in this case, we are restricting it to a domain, or we are restricting it to an interval. Okay, so okay, so let's see. Sometimes we only want to observe what happens over a certain interval, thus tracing only a piece of curve. Then, okay, then this becomes our parametric equation. Okay. All right, so let's do it this way. Just take this guy off. Okay, then what are we saying? Then this guy, this x equals this guy equals this guy, t between a and b becomes our parametric equations. And the curve, has what we call the initial point, f of a comma g of a, and f of b comma g of b. This is just like curve sketching, guys. Just like curve sketching. You put the end point, the left end point and the right end point. When t equals a, you have f of a. When t equals a, you have g of a. When t equals b, you have f of b and g of b. Okay. And this is what we call the terminal points. Okay. This guy, that's where we have the terminal points. Because I'm starting from A, then I'm ending at B. So that means I'm terminating at B. Okay, so let's say an example, guys. Suppose we're given a parametric equation, x equals 3t minus 5, and y equals 2t plus 1. Now, of course, what kind of parametric equation is this? This is linear, right? Because the highest power of t is 1. So if I have a linear, if I'm going to sketch, of course, I know it's going to be a line, right? So what can I do? In this example, you don't have an interval. So whenever you don't have an interval, you can decide to pick an interval of choice. Now, when you pick an interval of choice, you don't want to pick an interval like, let's say t is between -10 to 10. I mean, that's a whole lot of interval. You may not have the time to do that. So let's just pick something small, guys. Let's assume that t is from -2, -1, 0, 1, 2, 3, 4. So suppose t is between -2 and 4. Okay, so you don't want to pick a too much or too long, too large interval. Now there will be a corresponding value of x, and of course there will be a corresponding value of y. So now how do we fill this box? When t is -2, you go ahead and plug in -2 here. So you kind of have x equals 3 to the times -2 minus 5. And this is like -11. So that means this guy is -11. When t equals -2, what is y? Okay, y is 2 times -2 plus 1. And this is pretty much -4 plus 1, you got -3. So you do the same thing. When t is -1, plug it in this equation, you will have a -8 here. Over here, you have a -1. Okay, this is just a fun thing, right? Something to play with. When t is 0, 3 times 0, you got 0, 0 minus 5, this is -5. So you can keep doing it. When t is 1, you have a -2, the y is 3. When t is 2, you have a 1 right here. And over here, you have a 5. When t is 3, you have 4, 7, and then 7, 9. So remember, you can keep the domain or the interval short. You don't have to do something that is very long, okay? When it becomes too long, it takes a lot of time from you. Okay, I hope it's making sense so far, guys. So now let's move to the part of sketching, right? We need our parametric curve. This is my x-axis, of course, this is my y-axis. Now, the same way you sketch curves as a pair, when x is -11, y is -3, right? When x is -8, y is -1. Okay, so you can just, continue to sketch in those, in that manner. Okay, you can sketch in that manner and then you're good. X is negative 11. This is X. So suppose here I have a negative 11. Y is negative 3. Negative 3 is like, let's assume over here we have a negative 3. That means we're talking about these points. When X is negative 8, Y is negative 3. Suppose here we have a negative 8. I mean, when X is negative 3, Y is negative 1, I mean. So that is this point, okay? When X is negative 5, Y is 1. So assume this guy is negative 5. Y is 1. Suppose this guy is 1. And that is this point. I mean, this is the basic curve sketching, guys. So when X is negative 2, suppose this is a negative 2 here, Y is 5, right? Y is 3. So suppose this guy is a 3. Suppose we just have a 3 somewhere here. That means we have these points. So we keep doing the same thing. And as you keep going, you have something else like this. You have something else like this. So pretty much it has to be a straight line, okay? So forgive me, I don't have a ruler. So let me just try to pull up a straight line here. Okay, so I'm going to make sure it's aligned because it has to be a straight line. So assume this is a point. Assume we have another point here. We have another point here. Okay, it has to be a straight line because these are linear. All right. So at this point, you have a negative 11 comma negative 3. Okay, over here you have negative 8 comma negative 1. That's just what you're plotting, right? Over here you have a negative 5 comma 1. Over here you have a negative 2 comma 3. Over here, suppose I have 1 comma 5. Suppose here I have 4 comma 7. If I continue, then I have this 7 comma 9 as well. Now this is the curve. However, remember that we used arrows to indicate the direction at which it is increasing. Now from negative 2 to negative 1, this guy is increasing, right? Okay, negative 2 to negative 1. Negative 1 is bigger than negative 2. 1 is bigger than 0. Okay, so how is the arrow going to look like? It's going to be pointing upwards. Because you're going from the smallest to the largest. Okay, smallest to the largest. And that's why this guy, you have the smallest number right here. Okay, so you're going from the smallest to the largest. All right. I hope that makes sense. So there's just one more thing we need to do. And this curve we actually trace now. For every curve you draw, there has to be an equation of the curve. So I want to ask the question, which curve is traced out? Okay, so which curve did we trace? Now, how do I do that? There's something we call eliminating parameters. So the action is we have to eliminate the parameter t. We have to eliminate the parameter t. Okay, so what do we know, guys? We were given that x is 3t minus 5, right? And we're given y is 2t plus 1. Now the question is this: is it possible to combine these two equations and the only thing I'm going to have is x and y? I don't want my t anymore. I just want to combine these two equations into a single equation of only x and y. Is that possible? Okay, the answer is yes, guys. So, and how can I do it? I just have to go from here, okay? Make t the subject of the formula. So you have 3t equals x plus 5. my t is actually going to be 1/3 of x plus 5. Now remember, when you eliminate the parameter t, you don't want to do with t anymore. You just need one equation of only x and y. Okay, so that means I can actually plug this t, I can plug it here. Okay, that means my y is going to be 2, right? Multiplied by, what is t, this guy? 1/3 x plus 5. Then remember, I got a plus 1. So let's see. So y equals, you got a 2/3 x plus 5 plus 1. So now let's FOIL this guy. You have a 2/3 x plus, you have 2/3 times 5. You do have a 10/3 plus 1. Now, when you combine these guys, pretty much what do you have? This is equal to 2x/3. And this becomes plus 13/3. Perfect, guys. So can you see this guy is strictly an equation of only x and y? I don't have t anymore. So what does that mean? It means that this straight line curve that I drew, this is the equation of this straight line curve, this guy. Okay, I hope this makes sense, guys. Now we're going to try something a little bit different. Now the first one we looked at was pretty much linear. Okay, so but in this case now we really want to look at the case of, what if I have a quadratic guy? What happens? All right, and that's exactly what we want to do. Okay, so another example. In this case, suppose that we have, so the question can come like this: sketch and identify the curve defined by, okay, by the parametric equation x equals t squared minus 4, and then y equals t divided by 2. Let's use something, let's switch it up a little bit. Let me use different equations. Let me use 1 plus 3t, and let's use 2 minus t squared, okay? All right, so how do we deal with this solution? Now, in this case, again, similar thing, we don't have like an interval, we're not given, so I'm free to choose. So remember, you want to choose you don't want to choose a too large interval, for the sake of time. So I'm just gonna play it safe, guys. Let me just choose from -3 to 3. 0, 1. Okay, 2 and 3. How do I determine x and y? The same thing we did in the previous example. When t is -3, plug it in this equation and plug it in this equation. What do you get in the corresponding answer? Let me just do the first one. X is going to be 1 plus 3 times -3. And this means that my x is just going to be a -8. What about y? 2 minus, got -3 squared. And this is like 2 minus 9, which is -7. So this is a -8, -7. So you can do the same thing for all of the t's. So if you do that, I'm just going to tell you what it's going to be. -2, 1. This is going to be 1 and 2. It's going to be 4, 1. This is going to be 7 and -2. And the last guy, 10 and -7. So what's the next thing I want to do, guys? This is just the table. This table helps me to pull up my sketch or to pull up my curve. Okay, remember to always label your axis. Now these guys are pairs again. They are pairs. So how do I calibrate this guy? When x is -8, y is -7. When x is, So that means that we can intuitively pick points. Okay. Let me pick this guy. Suppose over here, x is -8 and y is -7 here. So I can come here and pick this point. You can just use a dotted line. It depends on you. Or you can use an asterisk. So when x is -5, y is -2. So suppose here we have a -5, and suppose we just have a -2 somewhere here, okay? These are not drawn to scale, guys. Not drawn to scale, just it's a sketch. So if you keep doing this guy, at the end of the day, you're gonna get a parabola facing down, okay? So let me just sketch my parabola. So suppose my parabola looks like this guy. Okay. So we assume that, okay, because I'm not drawing to scale, that's why I can do this, guys. If I'm drawing to scale, I'll make sure that everything aligns. So over here, we'll call this guy -8, -7. This is -5, -2. You pick a point here, -2, 1. Let's call this guy 1, 2. Okay, so this guy, this is a 4, 1. And over here, suppose this guy is 7, -2. And over here, say we have a 10, -7. Okay, this is half of the job, right? Remember, we need the arrows, okay? Because we're dealing in t. There's a change with respect to time. So there are two possibilities. Is either my arrows are going upward, right? Or they are reverting. So we need to determine whether they are ascending or descending. Now, how do I do that? I'm going to come back here. I'm going from -3 to 3, right? This is increasing, okay? So if you look, that means what happens, you're ascending, okay? From the smallest guy to the biggest guy. This is from the smallest guy to the biggest guy. Okay, this is -3 to 3. -3 is the smallest, +3 is the biggest. All right? So now, but what's the last thing we're left to do? It says identify the curve. Okay, so we got to fix this part. And how do I identify the curve, guys? All right, so that's going to be, we're going to eliminate the parameter t. Now, 10.1 is fun, guys, just something to play around with. So what are we given? We're actually given x equals 1 plus 3t and y equals 2 minus t squared. I need to get rid of t. I'm going to do the same thing as before. Make t the subject of the formula. And t is going to be 1/3 x minus 1. So again, what do? I'm going to plug this guy, plug it back here. All right. So that means y is going to be 2 minus t squared. That's a 1/3 x minus 1 all squared. Okay, so let's see, what does that mean for us? That means y equals 2 minus 1/9 x minus 1 all squared. Now you have to simplify, all right? So you don't just stop at this point. You got to take, you can, it depends on, how you visualize some of these things. I can actually stop here, but if I want to go a step further, then I have to open up, right? So I'm going to leave, just going to stop at this point. Okay, and essentially, so this describes the curve. Whether you simplify or not, this gives you the curve. Okay, but many a times, if you can, try to simplify. Okay, does this make sense, guys? Okay, so let's actually proceed. Now, you could have a question, guys. Can this be the only case, or what happens? Can we have something that deals with trigonometric functions? The answer is yes, guys. The answer is yes. So let's see what curve is represented by the parametric equations x equals cosine of t, y equals sine t. In this case, we have an interval from t is from 0 to 2 pi. Okay, t is from 0 to 2 pi in this case. Now, we got to set up our table. T, x, y. Okay, this just says 0 to 2 pi. So if I like, I can just segment this guy. Okay, pi over 6. I can pick pi over 6 as a distance, or I can pick pi over 4. So it all depends on, what I want to achieve. Okay, so when t is 0, cosine of 0 is 1. Sine of 0 is 0. So this is going to be square root of 3 over 2. This is 1/2. This guy is square root of 2 over 2. This is square root of 2 over 2. Cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. And this is 0 and 1. So again, I need to sketch. What do I know, guys? This guy is 0 when it comes to trigonometry. This guy is where we have a pi over 2, right? This is 3 pi over 2. I mean, this is pi, not 3 pi over 2. Sorry about that mistake. This is pi. And then you have 3 pi over 2. So this part is like 0 and 2 pi, if you remember that from your basic trigonometric knowledge. So essentially, if you sketch these points, you're just going to get a circle. This should just be a circle, okay? When x is 1, y is 0. So that means you have this point. When x is square root of 3 over 2. So that means you have something like this guy. You keep having this guy. It's just going to switch around. Okay, so you have pretty much a point here. You can have a point here. Something of that manner. But it's going to be a circle. Okay, so the next question becomes, in what ways will my arrow move? Will my arrow move like this? Or will it move like this? Okay, so these are different possibilities, guys. So different possibilities. Now, when x is 1, okay, when x is 1, of course, guys, over here, I just stopped at pi over 2. We have to continue this guy up to 2 pi. Okay, so I just stopped that for the sake of time. Okay. Because originally, of course, I know some of you had a question. Oh, why did we stop at pi over 2? But this is 2 pi. Yeah, I just stopped there. It has to actually go to 2 pi. Okay. So you guys can fill up this gap, but it's going to be a circle. Okay, sorry about my awful circle. Okay. All right. So we're actually going to move from 0 to 2 pi. 0 is the smallest and 2 pi is the largest. So this is we're starting at this point. We're going round up to this point. So that means this is the direction. Okay. Now, one more thing, guys, we need a curve. Okay. So how do we get a curve? Again, we have to eliminate t. What were we given, guys? X equals cosine of t and y equals sine of t. Now, whenever it's trigonometric function, you want to try to think in terms of trigonometric integrals, trigonometric identities, I mean, guys. Okay, so what trigonometric identity combines cosine and sine? Does that ring a bell? So do you guys remember sine squared t? Do you guys remember this fact? Do you guys remember that? Okay. So what do we see from this? What is sine squared t? Y equals sine t. So that means this is y squared. Cosine squared t, this is s squared. So essentially, what does that mean? That a curve is described by and guys, this is consistent. What is this equation? This is just a circle with radius 1. Okay? Just a circle with radius 1. Okay, so pretty much that is very consistent. Okay? That is very consistent. Now, suppose we have another question. Let's do another example. Now, this is eliminate the parameter to find the Cartesian equation. Okay. So we want to eliminate parameter to find a Cartesian equation. Okay, so what do I do? And then sketch curve. Solution. Okay, so in this case, we were given, I need to give you the parametric equation. 4 cosine of theta. Y is 5 sine of theta. And theta is actually between negative pi over 2 to pi over 2. What do we do, guys? This is another trigonometric identity coming to play over here. Okay, so I have to think about a trigonometric identity, guys. Whenever it's a trigonometric function, you want to think about trigonometric identity that combines the two things together. Okay, so this is cosine and sine. Of course, I know I have something like this. Start from the known to the unknown, okay? I know this already. Now, this guy is sine squared, this guy is cosine squared. But over here, things are looking a little bit different from the previous one. This has a constant, it has constant 4 and 5. From here, I know my cosine theta is just x over 4, right? Just do that kind of little algebra. So what does this mean for us, guys? This is going to be y over 5 all squared plus x squared over 4. I mean, x over 4 all squared. Equals 1. Okay. Now, do you guys remember, what is this? What equation is this, guys? Do you guys remember the name? Think about it for 1 second, guys. Okay, remember, guys, this is describe an ellipse with horizontal semi-axis 4. Okay, of course, I can just write this guy as x squared over 16, right? Or I can keep it in terms of the squares so that you can see the equation easily. So this is an ellipse with horizontal semi-axis 4 and a vertical semi-axis 5. Okay, it's just pretty much, it's an ellipse. It is an ellipse. So if I decide to sketch this guy, Okay. So, but what do I know, guys? I know I was given that x is 4 cosine of theta, right? And theta is between negative pi over 2 to pi over 2. Okay, so what does this connote? Will my x be positive? Will x be strictly positive or not? We can be able to check. Uh, you know, so an example is this: 4 cosine of theta is going to be positive between this interval, right? Okay, so that means that my x is strictly positive. So what does that tell me? This is x, this is y. It means this is the only dominant part on my x. But that's not the same story for y, because y is sine, right? So what does that mean? This is going to just be kind of a semicircle on this part. Okay, your x is, you have a 4 here, you have a negative 5 here, you have a 5 here. Now let's see, in terms, how does it increase? This negative 5 is the smallest number on y. 5 is the largest number, so that I'm going this manner. Okay, does this make sense, guys? So you have to kind of be familiar with the equation of the circle. How does equation of an ellipse look like? Okay, so those are things to be familiar with. All right, so those are things you want to that must come back to mind as you do this session. Now let's see what more examples we can be able to discuss. Okay, let me give you another example and then discuss one more last thing. Another example, if I give you this guy, and I ask you to find a Cartesian equation. That means Cartesian equation is just an equation in terms of x and y. Okay. So what is my expectation solution? What's my expectation when I say this, okay? For you to find a Cartesian equation. My expectation is just like that you should eliminate parameter t. Now, what do we do, guys? Remember, these are trigonometric functions, right? You think about a trigonometric function that combines these guys. I know that cosine squared of 2t I know this already, right? So, and what is cosine squared 2t? That's like a y squared plus x squared, right? And of course, this guy is, if you put x first, what does this describe, guys? A circle. You must be able to identify it, okay? A circle, okay? What radius? What radius 1? Make sense, guys? Easy, right? Now, let me discuss. Now, sometimes you can have different parametric equations, but they are going to describe the same Cartesian equation. Okay, that's possible. So different representation of the same curve. So what are we saying here, guys? We're saying sometimes you have different parametric equations again, but they describe the same Cartesian equation. Number one, an example of such is this: when x equals t and y equals t to the power of negative 2. Or all of these three guys, y equals e to the negative 2t, x equals cosine of t, and y equals secant squared of t. These guys, they all represent y equals 1 over x squared. You can try this, guys. Eliminate t from all of these three different sets. They will describe this same equation. And this is just the Cartesian equation, right? Okay. Let me give you another set, guys. There are a bunch of those sets that are unique in those ways. We have these guys. This is another set. T to the 6th power, then y equals t to the 4th power. This guy, all of them, guys, they represent y equals cube root of x squared. You can also try it. That's what you get. This is like cube roots, okay? Cube root of x squared. I mean, there are a whole bunch of these possibilities, okay? So you need to be able to think about them and come up with them. And of course, we have curves, we have, parametric equations too that are not easy to express as Cartesian forms. So sometimes you have very difficult functions, okay? So sometimes some functions or some possibilities are, so difficult, okay? All right, guys, so this is what I wanted to, show you from, what's it called now? Section 10.1. So let me just give you something to try. Okay, so this guy, so find the Cartesian equation. So hint, what is the hint, guys? What do you do, guys? Eliminate parameter t. Okay. All right, so I hope this whole session makes sense, guys. If it does, that's great. And of course, this video is, infinitely available infinitely many times. Please feel free to take a look at it and